Hello, my name is Dan Oak and I'm a student at Athabasca University, currently taking the course Comp 444 Embedded/Robotic Programming. And if you've been following the videos I've been posting to the course forum so far, you'll know that I'm going through the SparkFun Inventor's Kit Guide, and I'm showing you how I'm completing some of the projects as well as the associated coding challenges. And in today's video, I'm just giving you a progress report on Project 5, specifically my progress with Circuit 5B, where the original circuit has us use serial monitor communication to control the SparkFun board microcontroller set up with a couple motors and wheels, and in order to make it move forward and back and that sort of thing. So you're supposed to send like a command like F and a speed and go forward, and B and a speed and go back, and so forth. Turn left, turn right, that sort of thing. And for the original project, it is supposed to be tethered to the computer via a USB cable, and you can just do the commands in that way. But I wanted to untether it, so for the coding challenge, I decided to create this little remote control car. And this is all parts that didn't come in with the kit. Since starting the course, Comp 444, I've bought a lot of stuff on Amazon and AliExpress, just so I could do extra practice on my own. And as such, I've bought a couple motors, the same motors that come in the kit, wheels. I've got an Arduino Uno in here as opposed to the red board that came with the SparkFun kit. I've got this battery pack, got a couple lithium batteries, but in particular today, I'm using the nRF24L01 Plus modules. They're RF Transceiver modules that I've shown in a previous video. This is an internal antenna version, so a little shorter range, about 100 meters, as opposed to the external antenna version that has about 1,000 meters. But in this case, either would be fine, considering I'm only a few feet apart. But I'm using this, so I've created two codes for this coding challenge. One for the receiver, i.e. the little remote control car that I've got stored in that little Rubbermaid sandwich container. My kids have a million of these sandwich containers and don't need them anymore. So I'm repurposing a couple of them. And so I've got some code for that, where this code basically receives the commands. Try to do this one-handed here. On successfully. Where is it? Yeah, so it receives the commands, and ultimately the switch statement takes care of what we do. If we receive an F, we go forward, a B backward, L for turn left, R for turn right, S for stop robot, and T for toggle LED. And then I've created this code, which is the receiver code, which a lot of the code repeats itself as far as handling the RF transceivers. But the main difference is this code allows me, as you can see by the function I've created, handle serial input, allows me to type in commands and send them. And so we'll see if it works. So as you can see, this is something I created from a previous project using these RF transceivers. But I'm just using one of them now with the transmitter code, and then this other one has the receiver code, which is currently stored on this. And as you can see, I have it powered on. So we'll see if it works. So I just have to type in a command, so such as T. Oh, not in the code though, let's actually do it in the spot. So if I type in this command, T is for toggle the LED light. So when I type that, when I press enter, that light should turn on. Let's just see. I'm pressing enter now. Oh, failed to send command. Okay, I guess I've taken a while to set up this video, so let's try again. Okay, now it's sent the command. As you can see, the light's on. So that was just a timeout delay because I've been a while setting up the video, but I'll press T again and we'll see that it'll toggle off. So when I press it, it toggles off. If I press T again, it'll toggle on. So that's how that works. Now if we send F, comma, the way I've set up, F, comma, 75. Oh, I keep typing in the code for some reason. Trying to use the phone at the same time. So F, 75, this will make it drive forward at a speed of 75. That's how fast the motor is going to spin. It has possibility of spinning from 0 to 255. 255 being full power, and 75 obviously being a fraction of that, less than half. So let's press this and see what we do. And then I'm going to immediately press S to stop it before it gets too far. So press that. Now I've got S going in. And I'm going to stop it before it hits something. So right now. So again, this is still the preliminary testing, which is why it didn't necessarily go straight. I mean, it has to do with the friction on the floor. The wheels are a little splayed out because of how I've zap strap things. But this is just testing functionality. We can get it, you know, we can get it sorted later. That might just mean, I mean, the wheels do spin at different rates, so that might mean I create code that takes in a certain speed, but then it actually, you know, makes it a certain percentage that goes towards one wheel versus the other, because one wheel might just naturally spin better. I mean, again, these are all parts that come in the little kits. Their tolerances aren't necessarily that precise. But let's try it again. Let's go backwards this time. Actually, let's go forward again, just to give us some room. And let's go to higher speed, maybe 100, and send. And stop. And now I'm going to send backwards. So you can see I'm doing stop, S to stop it, backwards at 255. And then I'm going to immediately press stop because that's going to go fast. Jeez. So that came at me pretty quick. I was worried about the computer there. Let's try going forward at 175 and then stop immediately. Boom. Let's go backwards again, but just very slowly, maybe at 60. As you can see, not quite enough to even move one of the tires. So that's all right. I used it as a turn. Press stop. And now let's go forward at 200. And I'll get ready to press stop. Didn't even have to press it to hit that. Let's go backwards again. That's just 70. Nice and slow. Stop. We're going to do a left. Let's go right turn just to come towards us. Right turn at, let's see, 75. And you can see that's right turning. So with the right turn, I don't know if you noticed that one of the wheels is spinning forward while the other is going back. Particularly if it's a right turn, the right wheel would be spinning backwards and the left wheel would be spinning forward in order to have a small turning radius like it's doing now. Now if I stop that, and now I go left turn, left comma 100, we'll get a little more speed. This one, for left turn, the right wheel will go forward and the left wheel, if you pay attention, will go back. It might be hard to tell in the video, but again, this is the left turn at 100. Oh, stop the video by mistake. This is the left turn at 100 speed. So the left wheel is going backwards and the right wheel is actually going forward. And just to give you, because that's spinning quick, the left wheel will be the one opposite of the antenna. The antenna is near the right wheel. So you can see the left wheel is going backwards and the right wheel is going forward. I'm just going to stop that by sending the S command. And that's it. Forward at 60. Not very fast, so again, sometimes you have to do, I'll do backwards at 75. And get ready to press S. That's pretty much it. And another T. T will toggle that light on and off. I just did that for something else to do. Okay, that's pretty much it. I just wanted to show you the progress. I've still got more to do to this. Might add some IR capability so we can control this with a remote as opposed to having a camera out. I'm thinking of eventually controlling it via Arduino Cloud because I did buy an nRF24L01 Wi-Fi. I'm not using it right now, but and this is the setup. So I am using different components than the kit. So we have a different motor driver in the SparkFun Inventors kit, a lot more efficient than this one, hence why this one has this huge heatsink in it. But this is an L298, I believe it's L296 rather, L296N motor driver. it's got an interesting way it works, and it's a very common driver. However, it's nowhere near as efficient as the one that comes in the kit. So obviously that one is better, but this is the one that I bought cheaply off Amazon. So I'm just showing how that works. The coating's very similar, but that's pretty much it. So that's how I have it hooked up. This used to be the area to put frozen carrots, and now it houses the motor driver. And again, there's the Uno with all of the connections. I've soldered a 300 and 330 ohm resistor, I believe, onto the negative lead of this LED, and I've tied them to these couple of wires just so it could stick through. And again, this is the external antenna version of the nRF24L01 Plus module that, again, there's really no markings on it. I got it on AliExpress. And a couple motors just strap to the side here. But yeah, that's pretty much it. And a battery pack. So I'll come back with a further report in the future. But for now, see you later.